look at this afternoon for us is we are going to have a look at exactly what happens to the carbon dioxide when it dissolves into the ocean. So we're going to move over to this board, and we're going to be doing some quite serious ocean chemistry. Now, it's worth mentioning the stuff we're going to talk about is very high-level stuff. It's the kind of topic that university-level researchers are looking at the minute, but we're going to make sure that it's nice and simple so that everyone can understand. So, on the board here, I've got a diagram, and at the top we've got the atmosphere. The atmosphere is like the blanket of gases around the Earth. And one of the gases in the atmosphere is called carbon dioxide. Now, carbon dioxide is made up of one carbon atom, so we've shown this with the letter C, and it's bonded to two oxygen atoms, and we've shown those with the letter O. Now, carbon dioxide exists naturally in our atmosphere, but because of human activities like driving cars or generating electricity to power our homes, we're producing lots more carbon dioxide. And it can't all stay in the atmosphere. Some of it will dissolve into the ocean. When it does that, it binds with the water. So does anyone know what the chemical formula for water is? If you do, you can call it out. And if you said that it's H2O, you're exactly correct. So water is made of one oxygen atom bonded to two hydrogen atoms. So in our ocean, we've got lots of water. And as I said, the carbon dioxide from our atmosphere can dissolve into the ocean. And when it does this, it reacts with the water to form something called carbonic acid. Now, this carbonic acid, it doesn't hang around for long because it goes through a series of chemical reactions, and what happens is the hydrogen atoms, they actually separate, and they become something called hydrogen ions. So hydrogen ions, they exist in the water, and we're left behind with a new substance. It's called a carbonate ion. Okay, so you don't need to worry for now what the word ion means. You just need to know that when carbon dioxide dissolves in the ocean, it firstly forms carbonic acid, and that then splits into a carbonate ion and some hydrogen ions. Now, these hydrogen ions, they're going to cause us a bit of a problem in a minute, but we're going to forget about them for now, and we're going to focus on our carbonate ions. Carbonate ions are super important for lots of marine animals, as I'm about to show you. So over here on this table, we have a selection of some wonderful marine artifacts. These are all real, and they've come from real marine animals. And all of the animals on this table, they have got shells. And these shells are made of something really important called calcium carbonate. So all of these animals, they take calcium out of their environment, they react that with the carbonate ions. So that's what we just mentioned on the board a minute ago. And they then form calcium carbonate. And that's what all of their shells are made of. So in this first section here, we've got lots of shells from animals that are mollusks. So we've got clams, we have got a nautilus shell here, and a nautilus is very closely related to animals like squid, octopus, and cuttlefish. Now, these are all called mollusks, and other mollusks include marine snails. So these shells have come from these marine snails. And whilst an octopus and a marine snail seem very different, they're actually part of the same mollusk group. And a little bit later in the show, you're going to see a cool experiment about snails. If we move along slightly, we've also got in this middle section here some crustaceans. So we've got a European lobster and a crab. This is an edible crab. Now, these are not the animals themselves, they're just their molts. So this is where lobsters and crabs, they grow in size, but they can't stretch their shell. So what they have to do is they shed their shell, a little bit like a snake shedding its skin, and what's left behind is the molt. It's just kind of the outside shell of the animal. And then the animal can grow a new shell made of that calcium carbonate. Now, lastly, we have some corals. Corals are a completely different group of cnidarians. And the animals that live inside a coral, they are protected by this calcium carbonate skeleton. So just like all of the animals on this table, they have this shell for protection to help them survive and to keep away any predators. So we can see that carbonate ions are so important for all of these animals to make their shells to enable them to survive. So, with that in mind, I would like to introduce you to a very good friend of mine. Here we have got my wonderful friend, Ian, and Ian is an edible crab. Now, Ian, could you please turn around and show our audience your fantastic shell? Now remember, Ian's shell is made of calcium carbonate. So he needs those carbonate ions from the ocean to make his shell for protection. Now, Ian, you can face back towards our audience, wonderful. And I'm just going to go back to our diagram again. So here, we've got our ocean. And remember, our ocean is filled with those carbonate ions and those pesky hydrogen ions I said that were going to cause us a little bit of bother. So, for Ian to keep his shell nice and strong, sturdy for protection, he needs to get as many of those carbonate ions as possible. However, there's some hydrogen ions around, and they also want the carbonate ions. There's a bit of competition going on. So, in a minute, Ian, you are going to do your best to try and get as many carbonate ions as possible to help you build your shell. But you need to be on the lookout for those hydrogen ions. They're going to come in and try and grab them. I'm going to count you down, and you can go in 3, 2, and 1. Oh no, so the hydrogen ions have come in and they are starting to take away those carbonate ions. And remember, that's what our friend Ian needs to make his shell. So Ian, you have not been able to get the carbonate ions. And that means you're going to have to spend a lot more energy trying to find them. This then means that Ian's going to have less energy available to try and catch food. Meaning, you're going to be quite hungry. And also, because you've not eaten as much food, you're going to grow smaller in size. Now, this can have a long-term impact on the food chain. So a food chain is where you have different animals eating each other all the way up to a top predator. And they all really heavily depend on each other. So if Ian's body size has grown much smaller, the animals that would eat crabs, like Ian, they're going to have to find a lot more food to be able to continue having enough energy to survive, which is going to pose quite a big issue for them. Now, if this continues, if we keep putting lots more carbon dioxide in the atmosphere, it continues to dissolve in the ocean, producing those hydrogen ions, our ocean is going to get much more acidic, which can eventually cause animals like Ian to start to dissolve. Their shells will start to dissolve, which is going to, unfortunately, be the end. So, Ian, thank you so much. You've really helped us to understand what happens to carbon dioxide when it dissolves in the ocean. So, we are just going to end this section having a little think about some positive things that we can do to help our friends like Ian and other animals and habitats in the ocean. So a couple of weeks ago, when you saw my friend Becky, she asked you to have a think about some things you can do to reduce how much carbon dioxide you are responsible for emitting. Now, you entered some of your ideas online, and these were fantastic to read. If you didn't have a chance to think of any, that's not to worry. We're going to talk about some now. So these are all things that you can do to reduce what's called your carbon footprint. One thing you could do is just reducing how much you drive. Now, I doubt many of you have driving licenses yet, but I'm sure we're all responsible for sometimes asking our parents or our grown-ups at home to give us lifts to places that we could probably walk, cycle to, or even get the bus. Other things that we could do is making sure that we switch off any electrical appliances that we're not using. For example, leaving the lights on, leaving the telly on, leaving your PlayStation or Xbox on. If we're not using them, then it's a really easy thing to do. It's just to switch it off on the wall so that it's not wasting any energy. Something else we can do is try to eat less meat. So meat is a really big contributor of carbon dioxide. Now, we're not saying that you don't ever need to eat any meat, but just by reducing how much you eat, it can have a really big impact on carbon dioxide emissions. And one last thing that we can do is just being really responsible about the things that we buy. So reducing, recycling or reusing things, especially plastic, can have a big impact on how much carbon dioxide is released into the atmosphere, which in turn will help our animal friends like Ian the crab. If you are stuck for ideas on what you could do, here at the Ocean Conservation Trust, we have something on our website that can help you. It's called our Think Ocean Challenge. So if you go online and search for Ocean Conservation Trust, Think Ocean Challenge, you can take our quiz and it can tell you what kind of shoal you belong to. Then it will give you a list of some ideas, some easy things you can do to reduce your carbon footprint and also help the ocean. So that's all from us here at the Ocean Conservation Trust today.